In section 5e, we have been discussing correlation. Correlation can be a useful tool to determine if there is a causal relationship between two variables. However, we also discussed that correlation does not imply causation. Here we're going to talk about 6 guidelines for establishing causality. When you recognize that there is a correlation between two variables, it is important to consider some other concepts in order to establish that causality. For number 1, look for situations where the effect is correlated with the suspected cause, even when other factors vary. If a scientist does not consider other factors in the correlation as a indicator of causality, then they are leaving out possible situations that might explain that causal relationship as mediators or confounding variables. And so for number 1, be sure to look for situations. So sit back and think about whether the effect is correlated with the suspected cause, even when other factors exist there. For number 2, among groups that differ only in the presence or absence of the suspected cause, one should check that the effect is similarly present or absent. Back in the 80s, before it was established that smoking tobacco cigarettes led to lung cancer, scientists needed to establish that among groups of people that did smoke, in that group, then there was a stronger presence of lung cancer. In groups that did not smoke, people that did not smoke, then there was a lower prevalence of lung cancer. So among the groups that differ, check that high values in X correspond with possibly high values in the Y variable, and low values for the X variable lead to low values in the Y value. This would indicate evidence that there is a relationship, a causal relationship between the two variables. So this would be like number 3. For number 4, if the effect might be produced by other potential causes, make sure that the effect still remains after accounting for those potential causes. I talked about this a bit before. You should consider in any research additional or outside causes, so confounding variables or mediators. After taking into those account, if the relationship still exists, then that does leave room for causality. For number 5, when possible, the suspected cause should be tested with an experiment. Random sampling is vital in a well-developed experiment, and there should be a control group and a treatment group in such an experiment. Lastly, the physical mechanism by which the suspected cause produces the effect should be determined. So before closing that research study, the potential mechanism causing the causal relationship, if at all possible, should be clearly stated. So these would be the 6 guidelines for establishing causality that we should consider when using correlation to imply a causal relationship. To wrap up section 5e, we discussed correlation. 2 variables are correlated if one variable increases or decreases as another increases. Positive correlation is when the variables increase or decrease together. Negative correlation is when one variable increases while the other decreases. And no correlation is when there is no such relationship. The absence of a correlation suggests there is no causal relationship between 2 variables. So a spurious relationship, no correlation, that would mean that there is no causal relationship. However, it is important to remember when working with correlation that it does not imply causation. The 6 guidelines for establishing causality between 2 variables are helpful before assuming that there exists a causal relationship between the 2 variables. When looking at graphs, remember that positive correlation, when you are given perhaps quadrant 1 with the x and y axis here, positive correlation is when you have a linear relationship with a positive slope. Negative correlation is when you have a linear relationship with negative slope. And no correlation is when no relationship seems to exist between the two variables. There are a few examples that you will be reading in your homework, and I have a few that I will go through briefly here. If we were to graph the age of a car against the number of miles on its odometer, the age of a car has to do with time, so this would be our independent variable. The y variable would be the number of miles on the odometer of the car. These two variables seem to have a positive correlation in real life. And if you think about that, though there could be outliers, there might be an owner of a car that leaves that car in the garage for 30 years, and it's a very valuable Corvette, something like that. However, tendency is that as our cars get older, we drive them more often, and so these increase together. B, the amount of groceries purchased and the length of time it takes to check out. Because that length of time there is dependent on the amount of groceries that one purchases, then this would be our X value, amount of groceries purchased, and then our Y would be the length of time for checkout. When we graph these two, we will be in line longer if we are purchasing more groceries. We will be in line shorter if we are purchasing fewer groceries. So because these increase together, these have a positive correlation. The amount of time studying and an exam grade, while students may not suspect this, teachers see this repeatedly as a positive correlation. So when students spend more time studying or spend more time in MyLab Math or Alex doing math, then their grades tend to increase. While this is a bit different on the extreme values, overall this is a positive relationship. For these first three here, especially it was B and C, we would suggest that there is a causal relationship between the two variables. For D here, as crude oil becomes available, the price tends to decrease. We saw this during the global pandemic. As crude oil was suddenly available, as there were fewer people traveling, then the price of gasoline decreased substantially. So these two variables have a negative correlation. For part E, as a car increases, its value decreases. So if this were my X value, the age of a car, our Y value is decreasing over time. These two variables have a negative relationship. The last row that I have here is just to remind you that though there may be a correlation between two, so I showed a graph before, and crude oil, the amount of crude oil purchased in the US and the amount of chicken eaten in the US, these were positively correlated. However, this correlation would not imply causation. These may have a confounding variable or a mediator, or may have a completely spurious, non-related relationship between the two. So it is important to consider those 6 guidelines for establishing causality that we discussed.